Hi, this is Alex from devstories.eu. High Performance Python Async, Episode 3 of 17. You optimize your indexes, upgrade your network, and tune your queries, but your application is still burning CPU cycles on database communication. The biggest bottleneck in your database queries often is not network latency. It is the time your application spends parsing text. To eliminate this overhead, we are introducing asyncpg and its implementation of the PostgreSQL binary protocol. It is a common misconception that asyncpg is just an asynchronous wrapper around signup 2. It is not. It is also not an adaptation of the standard Python DB API. The DB API specification inherently guides database drivers towards certain standardized data handling patterns. Asyncpg ignores this specification entirely. It is a ground-up rewrite designed exclusively for async I/O and PostgreSQL, bypassing standard database interfaces to talk to Postgres on its own terms. To understand why this design matters, look at how traditional drivers handle data transfer. Most database drivers talk to PostgreSQL using a text-based format. When you query the database for a number, a timestamp, or a complex array, the database takes its internal memory representation of that data and converts it into a string. It then sends that string over the network. When your Python application receives it, the driver has to parse that text string back into a Python integer, datetime object, or list. Think of this traditional approach like a team relying on a translator for every internal conversation. The database reads its native data structures, writes them out as standardized text documents, and sends them across the wire. Your Python application receives these documents and painstakingly translates the text back into its own structured memory objects. All this encoding, stringifying, and parsing burns CPU time and consumes memory. Asyncpg solves this problem by speaking the PostgreSQL front-end and back-end binary protocol directly. It forces the database to use binary input and output exclusively. Instead of relying on a translator, the database and the driver speak the exact same native language. If you query for a 64-bit integer, PostgreSQL sends the raw bytes representing that integer. Asyncpg reads those bytes directly into a Python integer object. There is no string formatting, there is no text parsing. This native understanding extends to complex data. When you request a JSON block, a universally unique identifier, or a geometric data type, the binary protocol ensures the payload remains compact and strictly structured. The driver knows exactly how many bytes to read for each column without ever scanning for text delimiters. Here's the key insight. The speed of asyncpg does not primarily come from the non-blocking nature of Python async. The massive performance gains come from stripping out the text translation layer entirely. You are doing significantly less work per row returned. By strictly enforcing binary data transfer, your application stops wasting resources reading text and spends that CPU time executing your actual business logic. That's all for this one. Thanks for listening and keep building.